What's up? This is solving equations with variables on both sides. The first thing I would like you to do, pause this video, write this down. We're going to solve equations with variables on both sides. The process is a two-step process. Step one, we will combine like terms if necessary, and that's each side separately. Number two, we will choose a side with the least amount of variables, and that means the smallest coefficient, and then we will eliminate. Pause the video, write this down, a BRB. Told you I'd BRB. So here's what we got. We have an equation, we have variables on both sides. Now, what we're going to do is we're going to follow that two-step process. This is not solvable right now at this moment by following our normal steps because I have x's on both sides and I need to isolate that x and solve, and that means the x or the variable needs to be on one side or the other. Now, step one was combine like terms for each side separately if necessary. Right here, there's no like terms to combine. Right here, there's no like terms to combine. So now we're going to jump down to step two, which says choose the side with the least amount of variables, smallest coefficient, and get rid of it. So when I look at my x's, I see a 2x and I see a 4x. That tells me that this 2x, well, guess what? He's the smaller of the variables. So what I want to do is I want to eliminate him. Well, how do I make a 2x disappear or eliminate? Well, I subtract 2x. If I subtract 2x from that 2x, it will go away. Keep in mind, however, we're solving an equation. This is our balance, our fulcrum. We've got to keep it equal. So if I subtract 2x from that side, I will subtract 2x from this side. Now I will come down with all of my work. 2x minus 2x, well, that cancels out. Negative 3 comes down. 4x minus 2x, that's 2x plus 7. Nothing happened to him. As you can see at this moment, we now have a two-step equation. We've done plenty of those. This should be very easy to solve. So attach to x is a 2 by multiplication, 7 by addition. We get rid of the addition first. We're going to subtract 7. We're going to subtract 7. That's going to give us negative 10. That equals 2x. And then, of course, to get rid of that 2 that is attached right there by multiplication, we will divide by 2, divide by 2. And I'm going to wind up with negative 5 equals x. So I now have a value for x. Now, we're going to go ahead and do the three-step check. I will caution you here, however. If we are doing the three-step check, when we do that, now that we have variables on both sides, you will not know what's going to equal until you actually do the check. So if you're doing any of that cheat checking, this is where you'll be caught. So I'm going to do it over here. I'm sorry I can't keep going down because my board's only so big with this screen. So 2x minus 3 equals 4x plus 7. So that's my original equation. So now what I'm going to do is I'm going to take that value that I think x is, and I'm going to substitute it in for x. Now, this means I have to substitute it in on both sides. So I'm going to do that. I'm putting that negative 5 in here. That's the next step. Now, last step is to go ahead and figure out what this is. You can punch both sides into your calculator. You don't have to do it in your head. It's up to you. But if I do this, this is negative 10 minus 3, that's negative 13. This is negative 20 plus 7, it's also negative 13. That checks out. What I was saying earlier, I would have never known that it was going to work out to be negative 13 on both sides until I actually did the work. This checks out. This means that my solution is negative 5. For x, I'm like, okay, right? What's attached to x? Well, holy cow, there's x's everywhere. So anytime you have multiple variables, x's, whatever the variable may be, on each side, the first thing that you're going to do, that's at step one, is we're going to go ahead and combine like terms. So the first thing I'm going to do here is I'm going to identify and combine like terms. So on this side, I have a 3x and a positive 1x. Also have a negative 7 and a positive 3. So I'm going to start by combining that up. So the 3x and the 1x, that's 4x. The negative 7 and positive 3, that's negative 4. And that's going to equal, on the other side, I have a 5x and a 2x. I also have a constant of negative 1 and a constant of 9. So combining those, I'm looking at 7x plus 8. Now, at this point, it looks a lot like the problem we just did before. So once we do our CLT, or combining like terms, I'm now going to get a problem like I had before. So approaching this is where we say, okay, I got variables on both sides. I narrowed it down to a single bunch of x's here and a single bunch there. So I will choose the side with the least amount and I will get rid of it. 4x is clearly smaller than 7x, so that's the guy that I've chosen to get rid of. I'm going to get rid of him by subtracting 4x. That's how I eliminate him. What I do to one side, got to do to the other. So when I bring that down, the 4x is of course eliminate over here. Negative 4 equals 7x minus 4x is 3x, and then plus 8. That's a two-stepper. At this point, we should be able to turn and burn. I'm not even going to talk about it a whole lot. I'm going to subtract 8 from both sides, subtract 8. That's going to give me negative 12 equals 3x. And of course, last step would be to divide by 3, and I'm looking at negative 4 equals x. Okay? So now, at this point, I'm going to perform my check. I'm going to try to squeeze that in over here. So I want you to just pretend that I'm still moving down. Okay, I just can't. I'm limited with this screen. So rewrite the initial problem. And again, go back to the original problem. You don't want to start at another step, although you may be tempted to do so, because, hey, this one's easier to write. It's less work. But keep in mind, if you made a mistake from here to here, the check won't show. And the whole point of the check, make sure you didn't make any mistakes. So now, I'm going to replace x with negative 4. And I've got a lot of x's to replace. So it's going to look like this. Remember, parentheses, they're your seatbelts in math. You can never go wrong using the parentheses for substitution. So now I've got that mess. Now, this would be where I would highly suggest you simply grab your calculator and type it in. And my calculator is dead. All right, let's do it in our head. This is negative 12 minus 7 give you negative 19, negative 23, and 3. That's looking like negative 20 over here. On this side, that's negative 20. Minus 1 is negative 21. This is negative 8. So that's negative 28. I'm sorry, that is negative 29. I add 9. I'm looking at negative 20. So that does indeed check out. Again, please use a calculator. You can punch that straight into your calculator. This check should not require a whole lot of thought. Rewrite the problem, plug it in, grab your calculator, punch it in, verify that it works. Let's do 2 new. Now, we have 2 cases that we need to discuss. Now that we're dealing with variables on both sides, we have a new situation that can occur. And I've put that new situation up here. Both of these, however, will result in a different answer. Now, you're probably looking at that and going, I see something odd. Yeah, I do too. The odd thing here is, and I don't know if you had to combine like terms to get to this point, if you had other work to do before you get to this point, that may be possible. But I'm talking about once you reach this point. So anytime I take a look at an equation and I go, okay, I got variables on both sides, I've combined like terms, I've isolated, I've done whatever I had to do, and I go, now I'm going to choose the side that has the least amount of variables or the smallest coefficient. These two should make light bulbs go off in your head, bells, whistles, whatever. I look at that and I go, okay, I'm going to choose the side with the least amount. I'm like, whoa, they have the same amount. That's where your brain should be going ding, 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 ding. This means one of 2 things, and these are these cases. So we'll follow along. If I decide, okay, well, they're both the same side, so I'm just going to get rid of this guy, okay? So I'm going to choose to get rid of him. So I'm going to subtract 3x, that'll eliminate him. Of course, what I do to one side, I'm going to do to the other. But of course, if they're the same amount of variables and I decide to eliminate this one, and then I go to the other side and do the same thing, it will eliminate both. So what happens here is both sets of variables cancel out. Negative 7 comes down, and that equals, and the 2 comes down. So I get negative 7 equals 2, which I'm sure a lot of you are going, no it doesn't. And you're right, it does not. We're going to pause this guy for a second. This one over here, if you look at, you should probably look at that and go, okay, I know what's going to happen. Again, let's approach it from you just saw it. I've got variables on both sides. I'm choosing the side with the least amount. Oh no, they have the same amount. Ding, 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 light bulb's going off. What I'm going to do is say, okay, well, I'm going to get rid of this one this time. That one. So I'm going to subtract 3x here. What I do to one side, I got to do to the other, so I'm going to subtract 3x here. Again, the same thing will occur. Both sides are going to eliminate. I'm going to be left with -7 equals -7. Now, of course, this one is true. This one is not. So what does that mean? Well, if you think about this from a logical perspective, you're basically over here saying, I'm going to plug a value in for x. Choose whatever value you want. 2. I'm going to take 3 times that 2 and I'm going to subtract 7. Over here, I'm going to do the same thing. I'm going to do 3 times that 2, but this time I'm going to add 2. Well, if I'm putting in the same value for x, there is no way I can multiply it by 3, subtract 7. Do the same thing over here, multiply by 3, but this time add 2, and expect the answer to be true. It's just not going to work. So that means that this guy has no solution. No solution. So now we have an equation that just, there's no way it will ever work out. So when your variables eliminate and you're left with a statement that is not true, that is no solution. I get over to this guy. Now, think about this logically. This time I'm putting a value in for x. I'm going to multiply it by 3 and subtract 7. Over here, I'm going to put the same value in for x. I'm going to multiply by 3 and subtract 7. So my question is, what number will that work for? Well, when I think about it, it'll work for any number. Any number that I put in here and multiply by 3 and then subtract 7, and I do the same thing over here, multiply by 3 and subtract 7, I'm going to have the same value. So no matter what value I plug in for x, this will always be true. Now, what does that mean? Any number you plug in works. Now, in math class, we're going to call this infinite amount of solutions. And the reason we're going to call it that is because, well, it's true. Any number will work, therefore it's an infinite amount of solutions. But as we get further into our math, we're going to find other situations where there's also an infinite amount of solutions, but it may not be every combination of numbers. You'll see what I mean down the road. So, once again, recapping 2 cases. When you have the same amount of variables on both sides and you choose to eliminate them, both variables will eliminate. You're going to either be left with a false statement or a true statement. If the statement is false, there is no solution. If the statement is true, that means there is an infinite amount of solutions. That's variables on both sides. Hope you enjoyed it. See ya.